Hey guys, welcome back to my channel. Today we'll be solving this question, the integral of e raised to minus x sine x dx, and we'll be solving it by parts. So let's begin. So the by parts formula is u into the integration of v minus the integration of differentiation of u into the integration of v dx. I won't be going too deep into the process of using this formula. I'll just link my video where I've explained it so you can check it out if you don't know. So here we have an exponential term and a trigonometric term. Now in the Lie-8 rule, trigonometric comes before exponential, which is why we will be placing the trigonometric term as u and the exponential term as v, and now we can start applying this in the formula. So we have sine x into the integral of e raised to minus x minus the integration of differentiation of sine x into the integration of e raised to minus x dx. Now we're solving this I. I'm going to be placing this integral as I, and every step I do will be towards solving I. Okay? So I is equal to this entire thing. Now I is equal to the integral of e raised to minus x would be e raised to minus x upon minus 1 minus the differentiation of sine x is cos x into e raised to minus x. I can just write this as minus e raised to minus x. It doesn't make a difference. So this is minus e raised to minus x sine x. I can take this minus sign outside, and we have the integral of e raised to minus x cos x. We'll be solving this by parts again. This is the v term and this is the u term. So this is minus e raised to minus x sine x plus, now we have again minus e raised to minus x cos x. Same thing that I did over here, integrating e raised to minus x and keeping cos x outside of the integral, minus the integration of, now we have the differentiation of cos x into minus e raised to minus x, because I've just used the same formula again, and the integral of e raised to minus x is minus e raised to minus x. Okay, so this becomes e raised to minus x minus sine x plus minus, let's just keep this in the bracket for now. So this becomes minus sine x into minus e raised to minus x. Now the minus and minus will turn into a plus sign, obviously. This is the same thing. Minus e raised to minus x cos x minus this becomes sine x into e raised to minus x. Now this is what we started off with. This is exactly what we placed as I. So I'm going to replace this with I. Okay, so now I is equal to minus e raised to minus x sine x minus e raised to minus x cos x minus I. Basically, I have to find the value of I. Now I'm going to take I to the left side, and we can write that as 2I because this will become plus. Now since we don't have any integral term, don't forget to write plus c in the end. And now basically we find the value of I by taking this 2 to the right side. Now we know that I is equal to minus e raised to minus x upon 2 sine x plus cos x. If you want, you can write this as c by 2, or you can just leave it at c because it's an arbitrary constant and it really doesn't matter. One more thing that you can do is write c by 2, and then c by 2 becomes c dash, and just leave it, just write c dash over here. Really doesn't matter because anyway after differentiation this turns into 0. So now since we don't have any integral term which we are equating to I, this is the final value of I, and this is our final answer, minus e raised to minus x upon 2 sine x plus cos x plus c. So that's it for today, guys. Thank you so much for watching. I'll see you in the next video. Bye.